Hello, physical science students. Today we're going to learn about balancing chemical equations. So we have these chemical reactions and we can write equations for them, but they need to be balanced. So today we're going to learn why we balance them and also how. So what should I get from this video? 1. We should be able to identify a coefficient and a subscript in a chemical formula. 2. Using those coefficients and subscripts, can I list the number of atoms for elements in a compound? 3. I should be able to explain why we need to balance equations. It's actually a very simple explanation, and we already learned it last week. And 4, we should be able to follow our outline for balancing equations that you'll learn about here very soon in this video. So here we have a chemical equation. We have reactants on the left-hand side here. We've got N2 and H2. We're reacting them. They're producing a product of NH3, which is ammonia, in case you were wondering. So the reactants are reacting. The arrow tells me they're going to produce or yield a product on the right-hand side. So that's a review of what are both sides of my reactions called. So we have reactants on the left, products on the right. So last week we learned about the law of conservation of mass, which tells us that mass is neither created nor destroyed in a closed system. And we're going to assume for all of our reactions they're happening in a closed system. So what that means for us is if I start with 2 nitrogens, like this is telling me, then I should end up with 2 nitrogens. It's not like I'm going to add nitrogens or lose them if I'm in a closed system. So let's review. Subscripts are these little numbers that are smaller to the right of our atoms or elements. What this means is this is one molecule of 2 nitrogens. So if I add a 1 for my coefficient, I have one of these molecules, N2, and you see I have 2 nitrogens here. H2 means I have a molecule of 2 hydrogens. If I add another one and make my coefficient 2, that means I have 2 of these N2 molecules, so 2 groups of 2, so a total of 4 nitrogens. So for starters, we're always going to start out with at least one of each of these. If I just add one of each of these, I see I have 2 nitrogens and 2 hydrogens on the left, and then on the right I've got 1 nitrogen and 3 hydrogens. So if I bring a little handy tool here, I see that neither one of my nitrogens or hydrogens are balanced. They're not the same. So let's pick one first to try to make balanced. Let's start with nitrogen. Here on the left I've got 2 nitrogens. On the right I've got 1. So how am I going to make them balanced? Well, we're never going to subtract. We're always going to have to add to make these balanced. So I can't do anything to the left because it's greater than the right. Let's try to make this 1 nitrogen a 2. How can I do that? Well, I see this molecule has 1 nitrogen, so let's just add another molecule of NH3. I can see that my nitrogen is now 2. I've got 2 nitrogens here, 2 nitrogens here. Those are balanced. But what's the problem? My hydrogens are not balanced. I've got 2 hydrogens on the left, but I've got 1, 2, 3, 4, 5, 6 hydrogens on the right. So how am I going to fix that? Well, again, I can't subtract from this 6. I have to add to the other side to make this 6. So how do I make H2 6? Well, if I can only add 2 at a time, add 2 more, I get 4. Add 2 more, I get 6. And now my equation is balanced. I've got 2 nitrogens, 6 hydrogens on either side. So what would this look like if I didn't have this handy dandy tool here? If I'm just doing this on paper or for a test, how am I going to be expected to balance these equations? So here's our process for balancing our chemical equations. We're going to write down the number of atoms for each element on both sides of the chemical equation, first and foremost, and then we're going to pick one element that is not balanced and adjust the coefficient to add molecules to one side so that they are balanced, just like I just did with that simulation. And then we're going to have to repeat that second step literally until all my elements are balanced. So let's look at 2 examples of those. Let's try our problem-solving process with this equation. You've got phosphorus and oxygen combining to make diphosphorus trioxide. First, let's list out the number of phosphorus and oxygens on both sides. So here, I see a 4 is my subscript on my phosphorus. There's no coefficient yet, so I know there are just 4 of those phosphorus on this side. On the right-hand side, I see the phosphorus has a subscript of 2, so it starts with 2 phosphorus. On the left-hand side, subscript of 2 on the oxygen, so I've got 2 oxygens, And then here on the right-hand side, there's a subscript of 3, so there are 3 oxygens there. Okay, and we're assuming we're starting with one of each of these. So first thing, let's balance out the phosphorus. I see I have a 4 here on the left-hand side, a 2 here on the right. So how am I going to get those equal? I can't subtract from the 4 again, remember? So let's add another P2O3 molecule. Notice I did not just add a P2. You can't do that. If you're going to add another molecule, it has to be an entire molecule that I'm adding. So I have to write P2O3 again. So if I write that again, now I can see, okay, I've got 4 phosphorus, and now I've also got 6 oxygens. So my phosphorus are now balanced. What about my oxygens? Well, I've got 6 on the right, 2 on the left, so let's add another one here on the left. That gives me 4 oxygens, still not 6, so let's keep adding. Add another O2, that brings this total to 6, and now all of a sudden my oxygens are balanced as well. So the reason why when I add molecules I write it like this underneath it is because now I can just sit here and count how many of those molecules do I have. I've only got 1 P4, so you could put a 1 here or just leave it blank. The 1 is understood. I've got 3 O2s here, so what's going to go as my coefficient? I'm going to put a 3 there. And then I've got 2 of these P2O3s, so a coefficient of 2 goes there. And there's my balanced equation. Let's do another one. This one looks a little bit more complicated. We just really have a lot more counting to do, but that's fine. So first, I've got sodiums, phosphorus, oxygens, potassiums, hydrogens, and that's same on the right hand side as well. Alright, on the left hand side, I see 3 of these sodiums, I see 1 potassium, I've got 4 oxygens here, but I've also got 1 here, so I've got a total of 5 oxygens here on the left hand side. I see 1 potassium and 1 hydrogen. On the right hand side, I've only got 1 sodium, I've got 1 phosphorus, I see 1, 2, 3, 4, 5 oxygens, I see 3 potassiums, and I see 1 hydrogen. So the first thing I see that's unbalanced is the sodiums. So I've got 3 on the left, 1 on the right. So if I add another one of these molecules that has, or one of these compounds that has sodium in it, then that gives me 2 sodiums, but I want 3. So let's go ahead and add another one. And now let's recount. So now I've got 3 sodiums, those are balanced. I added 2 more oxygens. So my oxygen went to 7. And then I've got 2 more hydrogens, so that hydrogen went to 3. So notice how I changed all 3 of those numbers because I have to add entire compounds. I can't just add elements. Okay, well, now everything is balanced except the oxygens and hydrogens. Let's try to balance out the hydrogens. And I'm going to do the hydrogen first because I've got oxygen in 2 of my compounds, and hydrogen is only in 1. So if it's only in 1 compound, it's going to be easier to balance than if it's split up between 2. So that's just a general helpful hint when solving these problems or when balancing these equations. So I've got 3 hydrogens on the right, 1 on the left. So how am I going to get 3 hydrogens on the left? Well, add 2 more of these compounds that have hydrogen in it. So now I've got 3 hydrogens. Notice I also have 2 more potassiums, which would be 3. And I added 2 more oxygens, which makes
7. So now let's look and check. I've got 3 sodiums on both sides. I've got 1 phosphorus. I've got 7 oxygens, 3 potassiums, and 3 hydrogens. So I am done. So now what's the last step? Well, I didn't do anything to this Na3PO4, so there's only that one compound. I'll leave that coefficient blank because it's understood to be 1. I count 3 of these potassium OHs, or KOHs, so I'll put 3 there. I count 3 of these NaOHs, so I'll put a 3 there. And then the very last one, K3PO4, there's only 1. There's an understood 1 in that blank. And there's my balanced equation. I have the same number of atoms of all my elements on both sides. The law of conservation of mass is satisfied.